Yep, like Chase said, I worked with him on during the development of MER, and I stayed on working on Spirit and Opportunity for the life of the missions as a PanCam payload uplink lead. That is basically, the scientists decide what they want to do with the rovers every day. And some of that's imaging with the PanCams, which were the color cameras on the mast. And I would take their requests and turn them into pointings, into command sequences to take those pictures. So I did that for many years, and our software wasn't that great. And I just kind of started looking, the Curiosity rover happened, and then it sounded like we were getting another rover, Mars 2020. I was like, well, maybe I should take my expertise and write some software with it that could do this better than anything we have right now. So that's why I started working on Viewpoint this year. It's the front end that you see here uses the Unity 3D game engine. The server runs on Linux as a Docker swarm right now. So the whole thing's kind of mostly written in C#. There's some Python too, for some utility programs and this and that. But what this does is it uses kinematic models for the mast, the rover mast, and uses camera models for all the cameras, and 3D terrain that was made stereo picture data that were images taken from the rover, and it's all localized together so that you get a really accurate kind of rendition of where the rover is on Mars and what it's what the perspective of the scene is from the rover. So when you first load it up, it loads the most recent data. Right now we're looking at the Curiosity rover. I had versions for Spirit. Well, not for Spirit because that died soon. I had a version for Opportunity, and then I made one for Mars 2020. So this is the Curiosity version. When you load it up, it puts the rover kind of in its current location and loads data. But you can change that if you want to load, previous rover positions and previous data. And you have there's several different views you can look at from the scene. One's kind of an overhead one, looking at a high-rise mesh of where the rover is relative to the high-rise, and you can see that this is like the path that the rover drove on to get where it is right now. And then there's this view which I was showing before, where you kind of can float around the scene. And then there's another view where you're looking at the scene from the perspective of one of the cameras. See, right now I think this is the Mastcam 34, and so this kind of actively uses the mast kinematics and camera models to sort of view what the camera would see as you look around the scene from the point of view of the rover on the mast. There's a few different imagery types you can load. So right now I'm just looking at, there's a couple different mesh types. One is this type that JPL produces. The JPL makes meshes that are, very dense, vertex-wise, for rover planning. So, when they place the arm onto rocks and things, they want to make sure it's very accurate so they don't have collisions or things like that, or it also helps for modeling driving. But this has a much more dense vertex structure to them. There's computers having like that much mesh data. So I also create my own meshes, like lower fidelity meshes that have less dense vertex structure, so you can load more of them at the same time without. You can only just data as meshes if you have stereo data, that can be correlated, but out of the distance, you can't really do that. And sometimes you only take images with one eye, and you don't have the stereo pair. So it's often useful to also just show those 1D images just kind of projected out on the scene and kind of draped over what meshes you have. And so you can load images to do that as well. So that can help you to point at things like Mount Sharp in the distance. But right now, there's like a crazy amount of images taken from this position. So it's kind of slowing things down a little bit. So I'm gonna turn that off for now, just to make things easier to move around. In this camera view, when you're looking at the scene from the point of view of the camera, that's where you can make pointings. So what this is doing here is you're seeing a footprint or a field of view of the Mastcam 34 camera, and you can, create these, move them around, drag them around, and I've got snapping to get the correct overlap. You can, set what how much overlap you want each frame to have and snap them into place to kind of quickly construct mosaics of the scene, covering various features of interest that the scientists request, and move them around as you want. And so, and these pointings, the person that the payload uplink lead, which I used to be, can set the different parameters on them, like enabling different filters, setting the compressions, choosing which coordinate frame that they're pointed in. Some coordinate frames are better for certain situations than other ones. And these pointings will then be translated directly into command sequences. And what else did I want to say about that? And anybody can make pointing, scientists or polls. Anybody with an account can log in, and you can see pointings made by other people. And so as a payload uplink lead, scientists could, suggest this is, hey, John, this is the pointing I want to see, and I could see that and copy it and use it to design the actual sequence. So it's also a collaborative tool that way. Some things we also want to be careful of when we're pointing sequences is to make sure that there's no shadowing from the rover, because when we take images, we want them to be in full sunlight, otherwise you can't calibrate them radiometrically, so you can't really do science with them. So I've got a shadow modeling tool where you can see how the shadows change at different times of day. So if you know what time that your imaging observation will be, you can set the time for that time and verify that you're not going to be in shadow or not. And these little blue markers here, these are targets. Other tools, so Viewpoint automatically imports targets created by like the other planning tools. These blue ones were created by rover planners. It looks like for some type of arm activity, they were looking at this rock with some of the tools on the arm. And you can create your own targets as well in Viewpoint for pointing. Sometimes, let's see, this is the M34, which is a kind of a wide field of view, which, it's just kind of manually constructing pointings is good for that. But the M100, it's a little smaller. And if you're going to construct a large mosaic with this, it can take a little bit more work, especially if you want to move it around, because you can see, here, I'll just show you how these Hazel lines work. So see this grid here, if you're pointing in some kind of as-L frame and you have so many degrees of overlap, as you get closer to the bottom down here, your overlap can get over, you can get more overlap than you need. And so then you have to manually correct it every time you move something around. And that can get annoying, especially if you have a million of these little tiny pointings. And also for the upcoming mission for Mars 2020, we're going to have a camera with a zoom capability. So I made a tool to kind of quickly, define a region and create the correct overlap for that region. So you can go like this, set whatever zoom setting you want, and it'll automatically lay out frames for you. And it's kind of like a rubber stamp tool where you can just kind of move it around and then say create pointings here, and it'll turn those all into pointings. I'll get rid of that for now. Other things we like to do sometimes is subframe. So you can take image pointings and subframe them, and with the subframing view. We go down to this point of view here. You can move the arm to various standard positions to verify that it's not going to get in the way of your vision. If you're, let's say you're trying to point at something behind that, that wouldn't be good if the arm was there. So you can verify some certain standard positions, but also it allows you to load simulations that are created by the rover planners. So whenever they do an arm activity or drive, they create this file which kind of is like a movie of what the rover will do. And we also get telemetry back, and they make that into the same kind of simulation file that shows what the rover did after the fact. So you can kind of compare what was intended to what actually happened. So you can load up those as well. So here's like a drive that was done. Those green lines are the wheel tracks I just turned on. So, and you can play through that. And this can be helpful, especially during planning, to verify that, yeah, the arm position isn't going to obscure your view. Also for planning post-drive imaging, because you can play this, get the rover to the end of where the drive is expected to end, and look at the view from that position and plan imaging from that perspective, because sometimes we have to do that. Also though, sometimes if the rover planners are planning in drive, we want to do imaging mid-drive, like at some point during the drive where it's like, okay, let's say we want to end up out here, but on the way, scientists want us to stop and take a picture of something because there's something interesting out there, and we'll get closer to it along our drive. So then sometimes the rover planners appreciate, some input from, the camera operators of like where would a good place be to stop to have a good view of that. So there's another tool, joystick mode, where you can drive the rover in the scene and kind of put it where you want it, and it conforms to the mesh. It has like a settling routine. So then you can look at the perspective from, kind of anywhere in the mesh in the scene you want to look and make sure, you're not going to get shadowing of something from some mid-drive position where the perspective looks good, or what the lighting conditions will be, or how many pointings you'll need to cover something to. So let's say we stopped here and we want to get this whole region, then I can, whoops, never mind. I'd have to save this position and then create pointings, but you get the idea. It can just help for that. And then I can take this rover position and tell the rover planners what it is. And so they can drive there, and we can take that mid-drive imaging. There's also a, when you drive, whoops, just click something. Okay, when you drive, the rover planners plan to drive, but sometimes the wheels slip, and then the rover doesn't actually get to where they planned. And the rover doesn't really have, unless it uses something called Visidom, where it takes images along the drive and compares them, and it kind of self-localizes itself to correct for that slippage. It can lose its sort of sense. If it doesn't do that, it can think it drove 10 meters, but it actually drove 9. So then when you're trying to target something, it'll be about a meter off. And so for long drives, it's kind of too expensive to do that visual localization. So we have to kind of manually localize at the end of a drive. And you know, there's some people do that on JPL. There's like an official localization, but sometimes that doesn't work very well. And I have a tool, a localization tool, where you can compare imagery from a previous drive to the one now, and kind of drag and drop it into place till it matches to come up with a localization solution, so that you can point using old data in the current rover's drive frame and have it be very accurate. That came in handy a lot on Opportunity near the end of the rover mission, where we were on this very steep slope, and every time we tried to drive a meter, like the rover would, you know, slip like 10 meters. So I had to use that tool a lot to point during the end of Opportunity's mission. And well, that's kind of a good general overview. Should I take some questions?
Everyone just feel free to chime in. I do want to comment that I like that your hold icon is the shaka.
What was that?
Your pointer timeout is a shaka, which I really like.
Oh, yeah.
Yeah, I have one question. So you have in this image you're showing here, there's a lot of detail in the terrain. So of course, has the rover been there for a while to get all these pictures, really, or how does that work? If you get to a new place, you have all that detail, right?
Yeah, generally every time the rover drives somewhere, it'll take these like kind of low resolution black and white pictures of the scene. And Curiosity has really good downlink. It was much better than we had on MER. So it can get you know, a fairly, you know, really good kind of sense of the area, you know, with stereo data pretty fast after you drive somewhere. But you're right that I think they have been in this position for a very long time. I was looking at the simulations available, and it looks like they've been sitting here for many sols doing arm work. So, and I think that's also why there's so much mass cam imagery of the scene. They've just been sitting here taking mosaic, like panoramas.
Right.
So the scene right now is like probably, yeah, has a little bit more data than you might see, like if they're just, you know, kind of trying to get somewhere. I think yeah, you're right that they've been stopped here for a while and have taken a lot of imagery.
Okay, fair enough. Yeah, thanks.
There's a question from Ross who doesn't have a mic. Could you talk more about how your rover planners use direct viewed stereo pairs from the cameras versus the generated meshes from stereo derived DTMs? Do you guys use VR headsets for anything, or just game engine stuff on 2D monitors?
Okay, well, you know, it's I'm not sure how well I can answer that because I haven't seen the latest versions of what the rover planners use for a couple years. But what they did, generally what I saw is they used something like this. It was, I think, inventor format. It was something from 2004. They use like this archaic mesh format that is really hard to convert, but they do have some kind of headset thing where they can look at stereo pairs, and it was like it's kind of like the flickering type of view thing where I think, you know, you can get a stereo perspective, like one eye would see, the left of the pair, and your right eye would see the right of the pair using some kind of image flickering thing. But that was pretty old too. That was like technology from back in 2004. There was an attempt to do more like VR headset stuff like this with a tool called Onsite that they started developing. It was more for scientists than rover planners. Rover planners, I don't think, used it, but it was more for science planning, and I think it was based on Unity as well. And it would, kind of load up terrain meshes like this, and you could put on a VR headset and kind of walk around the scene. That kind of morphed into another piece of software called Astro, which is going to be used for science planning on Mars 2020. And that, it seems like they've gotten away from the VR headset thing. I think users kind of find just kind of this type of software to just maybe to be a little more, I'm just guessing, but just easier, because you can just you don't have to set up a VR headset and have everything load, and the view's just more crisp. Also, just looking on a screen. I'm not sure if they're going to bring that back or not, but right now I think it's more just like this, looking at 3D projected in 2D. But yeah, I think RPs, the rover planners, still use that some kind of stereo view like that for planning drives that are they're really the only ones who really need to have a good 3D sense of things, so they don't actually misjudge like a divot somewhere and get stuck or something. So I think they're the ones that use that the actual 3D view more than anyone.
I have a question.
How have you found? Go ahead.
Yeah, are the because I've been interested in making some stereo products. Are the meshes that you're using, I guess from the HasCams, are those available on the PDS?
Yeah, I know the raw or the images are. I'm not sure if the processed like XYZ products are or not. I think there was an intention to make them available, but I'm not sure if that's happened or not.
I think there's some for like the mass cams that are, and then some that aren't like made. It's a little unclear. Like I'm not on the science team, but I hear about.
Yeah, yeah, I'm not really sure. I get all the data directly from the operations kind of repository, big giant file system with all the stuff on it. So I'm not really sure what's on PDS or not. But I know they were planning to release the meshes, and I would assume like the XYZ products that have, it's basically a, 3D points per pixel that match up to an image. So you can just use the image as a texture over the 3D data. That's what I use to create these like lower fidelity meshes. And I would assume that, I think that they're trying to release those. I remember Bob Dean talking about that, but I don't know if they have. But that would be what I would look for something that has it either XYL for linearized or XYZ in the name.
How have you found Unity for this kind of development, for science as opposed to game development?
Well, I've been using it a long time, and it's changed a lot, so I've had to redo how things are quite a bit, which is okay. I mean, that's good. It's always been improvement. I think the most challenging thing about it is the UI. Trying to make all these dialogues and text and information and things like that, that games aren't really, you know, it's their UI tools are meant mostly for, you know, games. So, you know, making things like context menus, you know, they don't have that out of the box. You have to kind of design that yourself, and it takes a lot. Yeah, the UI just kind of takes more work than I think I'd like it to. Other than that, though, I think it's fine. The 3D stuff, it definitely makes that easy. Like, I don't really, have to do much work there.
I have a sort of related question, I guess, because like there's been a lot of progress in sort of JavaScript, like 3D frameworks recently. And I mean, if you're able to like compress your meshes or use like modern mesh compression algorithms like Draco, which like purports to be like JPEG compression, but for 3D meshes to allow like, you know, progressive level of detail loading and such. Like, do you think that would, like, have you like seen those like web technologies, like, do you think like that something like this could be implemented there, or are you like using like a lot of vertices? Like, do you have like are these meshes like millions or like hundreds of thousands of like cells / triangles?
Yeah. Well, let's see. I think the JPL ones have the most vertices, and well, yeah, for a long time there used to be a limit on the amount of vertices you could have in a mesh. I think it was like 65,000. So I'd have to break up these meshes into a bunch of parts, right? So Unity could load it. I could do the, you know, what we were talking about with the different level of details, but it doesn't make that much sense to do it, just because it actually, you know, that actually adds data to what the user has to download. The download times are already kind of big. Also, you're generally just using data that's right around you. It's not like you're in a game and you're, you know, like Legend of Zelda, walking over this mountain, you know, and you want to have something that's low polygon that gets progressively better and better as you get near it. Generally, you know, you're just going to sit in this region you're at, and because that's where all your planning is going to be. So I haven't seen like too much of a reason to try and do something like that. I'm not sure what you mean exactly by different types of mesh compressions, but I'm not sure if that would help at all, because basically to load these meshes into Unity, I kind of have to make them process them into a Unity type of mesh, and I package them into a thing called an asset bundle.
So that it's new. It's by Google. I think it's more like when you have a web browser and you want to like, you know, limit network I/O for your meshes. So I think you probably, if your use case seems to not really be necessary, as you said, like you're kind of just viewing all the data in the scene, and you're working within Unity, which I'm guessing wouldn't really support that sort of streaming 3D format, or like streaming compression of these things. That's more of like a web-enabled technology, like you see things like Sketchfab.
Yeah.
Like augmented reality, sort of iOS stuff. It's sort of more in that world. So that you can have like a really large mesh, but to start off, you'll like load just like, you know, the smallest representation of it that you can, that's good enough to look at.
Yeah.
And user needs to, they can zoom in and load the bits they need. But it sounds like a big re-engineering. It might not be much of a benefit at this point.
Yeah, you know, there is actually, you know, that tool I was talking about on site that became Astro, which is going to be the science planning tool for Mars 2020, does something like that. They probably, and they kind of make them into this merged mesh that, you know, when you don't have this nice stereo data, it falls back to the this lower level high-rise data, and it's not like separate meshes, but it's all this kind of merged thing, and they're in tiles. and there's a tile server which streams, yeah, you know, you get the low res tiles and then progressively higher res as they come in. So I know that, yeah, it's definitely to do. If you do the thing in place, it would be quite a lot of work to try and implement that. And I'm not sure that it actually, one thing I don't really like about the Astro like tile serve mesh is that since it's all merged together, it's a little kind of more blurry and less crisp than you know, actually having like the highest resolution one on top and the lower resolution one below it. So while I think it's actually, yeah, it's more you know, efficient for users to load, and it is actually over the web. It uses like the Unity, I think WebGL implementation, and so it works really well for that. And I think it's a great tool as well. I'd like actually to load their tiles someday if I have time to get to it, but I don't know. Yeah, for now this seems to work pretty well.
All right, cool. Thanks.
Can you talk about how this fits into planning? Because this is, so there's a science planning tool, which apparently has duplicate functionality. How does this fit in the operations workflow?
Well, this is a so their tool is going to be a general science team tool, and it's kind of, I think its main kind of core functionality is for choosing arm targets. So it's you know, the way things used to work, the RPs, the rover planners, were the only ones that had any kind of 3D modeling tool. And it was a pretty complicated tool. They're the only ones who could really use it. And so scientists would get images in their kind of 2D planning tool, and they'd, you know, put dots on it, say, hey, this little thing, we want to get that, and they'd make a target there. But that wouldn't really translate to the 3D rover tool. So the rover planner would have to, you know, be involved in the meeting and put targets places and project their screen so the scientists could say yes or no, and then the rover planners could validate whether that the arm could reach there or not, because not every point you pick on the terrain is reachable by the arm. Some might have, you know, safety concerns, or maybe the kinematic solutions don't work for it. Maybe the normal's not right. There's, I don't know, different problems there could be. So not every point you click on could be reachable by the arm. So the rover planners have to validate every target. So this tool is the first time that they're kind of putting some of that into the hands of the users, so the scientists, so they can choose a target and run a validation on it to see if they can place the arm on it. So that's kind of meant to help take the burden off the rover planners, because that eats up a lot of their time doing all of that. And I think that's the main kind of point of that tool, is for that, you know, and to, you know, provide some things like Viewpoint does with shadow modeling and other things, other questions that scientists often, you know, pose to the rover planners that, you know, take time out of